recording now, so we are recording. And as I said, if you have a question, you can type it into the chat box. I'll address the questions I got in the email as we go through this. But I'm going to start by going through these tests, the quizzes rather, the homework assignments, or what we're calling quizzes this semester, the weekly quizzes. Okay, so I'm going to get started. And this actually, several people had an issue with a couple of these. A researcher records for each participant in the clinical trial. Unfortunately, the way that you print out the PDFs from the quiz itself is not great, so you sometimes get stuff gets in the way. But it's the amount of alcohol that's consumed is one variable, and the cholesterol level is another variable. So we know amount of alcohol consumed might be ounces or drinks or something like that. So we know it's going to be a quantitative variable. So we can eliminate categorical. So we're down to these two choices: quantitative variables for alcohol. And cholesterol is also going to be a quantitative variable. It's going to be a number, 100, 200, 130, and so on and so forth. So correct answer there is going to be alcohol quantitative and cholesterol quantitative. Most people got that okay. This next one, some people had some issues with it. Researcher records for each participant in a clinical trial their race and ethnicity and the severity of their depressive symptoms. Indicate which, whether it's variables, categorical or quantitative. Now notice you only have two choices here in this question. It's either categorical or quantitative, right? So race and ethnicity, that's going to be a name or a label, right? So that's going to be a categorical variable. And now we're down to two choices, the second and the fourth. Now, severity of depression symptoms. We're not told exactly how that's expressed, but severity suggests that it is some sort of quantitative variable, either a number on a scale, 1 to 0, say 1 to 10, or perhaps it might be as simple as not depressed or slightly depressed and so on and so forth, which is kind of like an ordinal variable, which in a sense is more associated with quantitative rather than categorical. So severity of depressive symptoms, I would go with quantitative there, and I believe that's what Professor Weicker did also on this. Race, ethnicity, categorical. Season of the severity of depressive symptoms, quantitative. You could argue maybe it's a ordinal variable, good, fair, poor, and so on and so forth. But it's definitely not just quantitative. It's definitely not just categorical, which would be all the labels are the same. They have no relative values. Okay, examination of medical records of 10,000 women shows that those who were short and fair-skinned had a higher risk of osteoporosis. What kind of study is this? Anybody want to type in there what kind of study they think it is and why? The first word should be a giveaway, right? You're looking at the medical records of 10,000 women, right? So if you're looking at their medical records and you're not examining them and saying that we're going to follow them to see if they develop osteoporosis, which would be a prospective observation, right? Exactly. Thank you. It's already happened in the past, so it's retrospective. This would be a retrospective observational study. Okay, so not prospective because we're looking at medical records, looking back at whether or not they developed osteoporosis and whether or not they were short and fair-skinned and so on. Okay, among a group of men who were tracked for 10 years, those who had scored over 130 on intelligence tests were more likely to suffer depression, and those who had scored below 130 on intelligence. And a group of men who were tracked for 10 years, those who had scored, and so on and so forth. What type of study do you think that is? Okay, in that case, right, it's prospective, right? Because they assembled this group of men, they recorded what their IQ scores were, and then they followed them for 10 years into the future to see if they developed depression. Okay, so that one's going to be I believe prospective. If I get any answers that are different than what was marked up correctly before, you can feel free to tell me, call me out on it. Okay, which of the following is a reason to use randomization? We had a lot of people who got this wrong. To balance the groups on variables known to affect the response, right? To eliminate possible researcher bias, to balance the groups on possible confounding variables, none of these or all of these. Well, let's take a look at these. To balance the groups on possible confounding variables. Yeah, well, that makes sense, right? In other words, you take a random sample, you randomize the sample, because you don't want to take a population and sample only women, or sample only people that are right-handed. You want a random sample of the entire population. Okay. How about these others? To balance the groups on variables known to affect the response. Well, sure. If you think if you're looking at cholesterol levels, maybe it has something to do with obesity. You want to make sure that the group is randomly selected and balanced in terms of, whether there's skinny people, medium people, fat people, and so on and so forth. So those are known to affect the variables that you're looking at. So we already picked out two that should be, that randomization will help with. Also to eliminate possible researcher bias. In other words, if researchers selecting the subjects, right, that could introduce some bias. Right? Even as simple as if I was picking people out of a phone book. If I'm right-handed, I might pick more people on the right side of the each page or something like that. Something as trite or silly as that. You want to eliminate any of those three things. So the correct answer here was B, all of the above. Okay, Cespedes et al. Study can best be described as, well, what was a Cespedes study? Right? Anybody remember what that was about? Right? That was about preschools assigned different experimental conditions. 5-month educational and playful intervention, or the usual curriculum. In other words, we were taking one group of kids, randomly assigning kids to two groups. In one, there was an intervention. They had a special educational program, involved play therapy or something like that. The other group had the usual kind of study or coursework that they would get. So we were comparing one group to another group, one experimental group to a second group that's just the way it would normally be. Okay, so that would be a experimental study. Okay, everybody okay with this so far? Any objections to this? Good. Okay, let's see. Austin et al. Right, experimental study or observational study. And let me see if I can't find some notes on Austin. In Austin, let's see, it was a study on purging for weight loss and diet pill use. It was surveyed among 24,000 high school students in two periods, 2005, 2007. Obesity ethnicity information was also surveyed. Now, in that one, they collected data on purging and diet pill use among this large sample of students, but they didn't actually randomize it into two groups and look for is it different by ethnicity and so on and so forth. All they do is collect the data. So that would be an observational study, right? They were collecting information to understand how this population, the nature of this population, how these students behaved, whether or not they used diet pills, and so on and so forth. So that would be an observational study. If they took any of those variables, whether or not they used diet pills or didn't use diet pills, and divided it up into two groups, and followed them to see going forward if obese students used diet pills versus non-obese students more likely to use it, that might be an experimental study. But certainly what we're looking at here is an observational study. Okay. In SPSS, the variables are typically recorded. I'm going to start up SPSS so we can look at it in the background because we're going to need it anyway in a second. Let me let this little SPSS ball bounce up and down for about 10 minutes. While that's happening, we already know, I've discussed in class, that the cases are in the rows and the variables are in the columns. So in the rows, might be the individual patients or subjects, and then the columns are the variables, age, weight, so on and so forth. Okay. Oh, that's bad news. That's the first time I've seen that in a long time. Okay, I'm not going to save that output window, especially since it's bad news. The variables would go here, and the cases would go here, right? So when we open up some data in a moment, we'll see that even more dramatically. Okay, in SPSS, the cases are typically recorded in the rows. In SPSS, the variables are typically recorded in the columns. Okay, I'm not sure if I said that right first time around, but that's correct. Crude rates are preferred over age-adjusted rates. We have not had a chance. We've been so busy in the lab, we have not had a chance to actually do a demonstration on age-adjusted rates. Professor Weicha did a brief example of it, some calculations of it, but I really want to do it in the lab in a little bit more detail. Maybe in maybe one of these extra sessions, a voluntary session, I can do it, and we'll have it recorded so that students can go ahead and take a look at this. Where was I here? Now, crude rates are preferred over age-adjusted rates for comparisons between population groups or trends over time. Okay, well, let's think about why do we do age adjustment, right? This is question number 10, I think we're on now, right? 8, 9, 10. Okay, what are the crude rates? Well, the crude rates, say for instance, if we're looking at mortality, we might want to compare the mortality rate among women in New York City due to cardiovascular disease to mortality rate for men due to cardiovascular disease. If you do that, you're going to find out something interesting. More women are dying. The crude rates, just how many women per 100,000 women are dying from cardiovascular disease versus how many men per 100,000 men dying from cardiovascular disease. Just crude rates add up the number of dead people, divide by 100,000, and that's the rate per 100,000. The crude rates tell you the number of people that are dying in that group. Surprisingly enough, you're going to find out that women are dying at a higher rate than men from cardiovascular disease in New York City. Well, that kind of seems contrary to logic, right? Men are usually the ones associated with early cardiac death for a variety of genetic and behavioral reasons and so on and so forth. And that's what we've learned. That's kind of like what we always assume, isn't it? Well, the problem there is that women live longer than men. So what happens is if you analyze the population of New York City, there's many more older women than there are older men. By older, I mean women in their 70s, 80s, 90s. There's a much larger population of them. And in those age ranges, the rate of mortality from cardiovascular disease in those age groups is very high. So what happens is, since the population ages are different, a lot more older women, we get a lot more females that are dying from cardiovascular disease, not because they're more susceptible to it than men are, but just simply because the population of women is so much older on average than the population of men. Okay, it's so skewed towards that older population. So in fact, we're going to find out that crude rates are preferred over age-adjusted rates. Well, no, not really, right? I would say that's false, because that can fool us. If we just take the crude rates and the two populations we're comparing are not distributed the same way, we can be fooled into the wrong conclusion, just as I described. Okay, is that it? I guess there were 10 questions for that homework. That one went pretty quick. Okay, let's take a look at assignment 2. Or quiz 2. If I got it here. I think I got it open already. Where'd it go? I guess I'm going to have to go to desktop. And I'm going to go to quiz 2. There we go. Okay. I'll move that over so I can see it a little bit better. Okay, good. Don't see any questions so far, so I'm going to assume I'm doing the right thing if I don't see any questions. Okay, so which are the ones that I had that people had a lot of issues with here? Let me go back to this little note that I had. 4, 5, 7, and 9 are the ones that seem to bring up the most problems. 4, 5, 7, and 9. Okay, so let's take a look at this. The following histogram depicts the heights of 50 men and 50 women. Well, problem with that is that women tend to be shorter than men in general, right? So if you look at this histogram, we'll see that a lot of the women may make up the bulk of this group, and the men may make up the bulk of this group. This is exaggerated. In reality, if we really did this, these would be overlapping to some degree, right? Because there's going to be some women that are taller than some men, so they would overlap a bit. But it's very likely that the median or the most frequent heights for men and women are going to be different. And what we're going to wind up with is two distributions, a single histogram, but the distribution is going to be such that there's going to be a peak for the heights of women and then come down a little bit for the average heights between, and then we'll get another peak for the average height of men. So we'll get something that'll have two humps. Like what do they call a two-hump camel? A dromedary or something like that, right? We get two humps in there. And that would suggest, of course, that this would be a bimodal distribution. The mode is the most frequent value. So the most frequent value for women, let's say, was apparently 64. The most frequent value for men was apparently 71 inches. So that would have two modes, one mode for women, one mode for men. And so it would be bimodal, in other words. So bimodal would be the answer to this. Okay, and they only ask you to pick one of these things, so you don't have to worry about if you got that right. You're not going to have to worry about this. A nurse measured the blood pressure of each person who visited her clinic. Following is a relative frequency histogram for the systolic blood pressure readings for those people aged 25 to 40. The blood pressure readings were given to the nearest whole number. Okay, so let's see what we got. We have a distribution of people 100, 110, between 100 and 110. If it was 15% of the population, 35% of the population was between 110 and 120. Now, you could also imagine if we're representing 100, the total population was 100. If I made that up, this would represent 15 people, 35 people, 25 people. You know, obviously, it's not likely that the population or sample would be that rounded, but you could look at it as a proportion, or you could look at it as the frequency, the number of people within each group. Okay, but the way it's shown on the graph here, it's as a proportion. Approximately what percentage of the people aged 25 to 40 had a systolic blood pressure reading of at least 110 but less than 120? So at least 110 but less than 120 would be the people that are in this one bar. And that would be 35% of the people. Okay, is that everybody okay with that? Not 0.35%, 35%. I think somebody might have just picked out three. Maybe now that I see this, maybe I shouldn't have given half a credit for it because it's multiple choice, but it's 35%. Also, another good answer would have been if we're in here, this answer would have been correct if it didn't have the percentage on it, because then it's a proportion. You could describe this, the proportion, as 0.35, or you could also describe it as 35%, but not both. Okay, and in fact, to tell you the truth, you really, even if that were there, you really shouldn't. You should choose this one because it asks for the percentage, not the proportion, right? But really, kind of both would be right. Both would be right, assuming it didn't have the percentage after this one. A nurse measured the blood pressure of each person, but she's busy, right? Following is a relative frequency line for the solids, blood pressure readings there. Okay, we repeated the instructions. Approximately what percentage of the people 25 to 40 had systolic blood pressure reading less than 120? Well, this would be 120. Less than 120 would be the frequency of people in these two bars. So that's 35% would be between 110 and 120. And also qualifying would be the 15% of the people that were between 110 and 100. So the right answer there would be 35 and 15, or 50% of the people. Okay, still all on the same page. Don't see any comments. Don't see any people, getting irate or anything like that, so I'm going to continue. And I think that was one of the ones that people had problems with. That was question 3. And I think 4 might have been an issue for some people. Same description. Given that 200 people, this one a lot of people had issue with. Given that 200 people were aged 25 to 40. Remember, I just gave you an analogy that if this were for a, I'm sorry, I can't. Let me get to one you can see. If this represented a population of 100 people, this would if we read it correctly, 15% of the population is between these two numbers, and 35% is between. So, but if the population were 100, that would literally be 15 people. And this would be 35 people. And in this bar here would be 25 people. Now, if the population were 200, well, 15% of 200 is 30 people. 35% of 200 is 70 people, and so on and so forth. You'd have to adjust for that. So let me go back to the question. I think it was down here. Given that 200 people were aged between 25 and 40, approximately how many had a systolic blood pressure reading less than 130? Given that 200 people were aged between 25 and 40, how many had a blood pressure reading less than 130? So let's see. Less than 130 was 25% of the population, 35% of the population, and 15% of the population. So 15 and 35 is 50, and 25, that's 75% of the population. 75% of 200 is 150 people. So the correct answer there would be 150. I'm not checking against the answer sheet, so I'm assuming that if nobody calls me out on it, that I probably am getting this right. Okay, 150 people. Let me know if the logic of this escapes you, so I can take a quick, maybe spend a little bit more time on it. Okay, so next one. The proportion of adults aged 15 to 49 who are living with HIV/AIDS is 0.5% in Latin America. Oh, this grabbed a few people too. Is 0.5% in Latin America, 1% in the Caribbean, 0.9%, little less than 1% in Eastern Europe, and 0.6% in North America. Suppose we include the proportion for sub-Saharan Africa, which is 5% of the population, to this data set and calculate the standard deviation. Would you expect it to be significantly larger or smaller, or remain the same as the standard deviation of proportions without the observation from sub-Saharan Africa? Well, what is the standard deviation? The standard deviation is a calculation that gives us an approximation of the variability of the data. So let's look at what does it look like, how variable is the data if we don't include sub-Saharan Africa. 0.5, 0.9, 1.0, 0.06, they're very close together. There's very little variability between those countries or those continents, right? But now let's include, if we include sub-Saharan Africa, well, look how much different that is from the others. So if we include that in calculating the variability, in other words, the standard deviation, the variability increases dramatically. So it doesn't remain the same, not significantly smaller, and we are able to determine just from the data, it's hidden down here, but it's significantly larger. Okay, everybody okay with that? Because that I noticed come up. I would have to say that's probably the single question that caused the most problems. A distribution that has the right tail longer than the left tail is considered not skewed, symmetric, skewed to the right, skewed to the left. I'm going to draw this. I think this is worth drawing. Okay, we can leave our little note there, still up there. So this is a distribution that's skewed to the right. Okay, maybe it's income, right? Because we got a few guys, rich guys from Wall Street and Donald Trump and stuff like that. They're up here. The bulk of people are down here. When you get something like this, a normal distribution is symmetrical. If it's just due to chance, if it's just let me try and draw this a little better, because I'm trying to get it so that it makes some sense here. Okay, here we go. That's close enough, I think. A real normal distribution is symmetrical. The mean, the average, is in the middle. This side is symmetrical to this side. Same number of people in this side as there are in this side. The median, which is the middle value, and the average, the mean, are the same. Mu and the median are the same, right? So now what happens? We know that mu is sensitive to, let's say that we get people with a very high income that are included in this population. Those people will tend to bring the average up. So it will take the mean, right? It won't have much effect on if this is relatively few people, the middle value is probably going to just inch up just a little bit. The median is going to stay close to the center here, like half the people are in here, half the people are in here. So it's not going to change that much. But these people here, they're going to tend to pull the average, the mean, right? They're going to tend to pull the average or the mean above to the right of the median if it's skewed to the right. This is the, let me do this a little clearer. Median. I'm going to try and remember to print because I know my handwriting is usually pretty good, but when I'm using these like small, tiny little small graphics tablets, it's easy to kind of scribble a bit, especially since if you don't lift your finger, you don't lift it off the tablet very high. So here's the median, and the mean is pulled away to the right. That's skewed to the right. Or you can also, since this is kind of a number line here, or skewed positively. It's positive skew or negative skew. So if we have something like this, right, that would be skewed to the left or negatively skewed. Okay, so we have some people with very low incomes, let's say, right? They pull the mean down, but the median, the middle value stays pretty close to the middle. I'll give you an example. We have 35 people in the class. When you people get your MPHs or whatever degree, or MSs for EOHS guys or whatever, when you leave here, let's say we come and we survey you and find out what your salary was for your first job after getting your MPH. And we find that the average salary, right? The average salary, let me rephrase that. The median salary for 35 people, right? N equals 35. The median salary for 35 people is, I'm going to be generous and call it $80,000, right? But then one of you gets drafted by the NBA and gets a $10 million bonus, right? So your salary for that year is $10 million. What does that do to the average? What does it do to the median? Well, the median doesn't change because really it's still just one person. So maybe the median becomes 80,500, 80,100. Not going to change much, right? It's only going to change assuming that guy would have been on the low side of the median, not the high side, which would have changed nothing, right? But now the mean becomes $200,000 a year because this one guy is making so much money. So which one is more representative of where the middle of the range of salaries is? Well, clearly the median is a better description of the middle income rather than the mean in this case. And that's because there's so much skew. Normally the mean is a perfectly good, in a non-skewed distribution, the mean is a perfectly good way of describing the middle. But when you have something that severely skews the data like this, you have to maybe fall back to the median as a better description in the middle, or maybe consider that an outlier. Let's not count him, right? That's not really a valid situation for this. Okay, so I hope that makes some sense. So this, since the right tail is longer than the left, it's going to be skewed to the right or positively. A recent survey, well, let me just see which other questions on this were an issue. 4, 5, 7, and no, 9 was an issue. Okay. Recent survey polled a sample of male Mexican-American adolescents to determine the association between smoking and unhealthy behaviors. Below is the data. Each boy aged 10 to 18 was classified according to smoking status and his response to whether he liked to do risky things. Okay, so age 10 to 18, they're like, I guess, from sixth grade to, I guess, fifth grade to seniors in high school and stuff like that. You guys remember a song, "Smoking in the Bathroom"? "Smoking in the Boys' Room." It's the name of the song. If you don't remember it, you can Google it later on. Smoking in, at any rate, brings back memories. But at any rate, we're talking about smoking. Young kids that are smokers versus non-smokers. And then we had some way to evaluate whether they liked doing risky things or they didn't like doing risky things. Who knows? That might have been based on some teacher's report or something like that, or maybe they just simply asked them what kind of activities they liked. What proportion of sampled smokers likes risky things? So the real key here is that we're only looking at smokers. How many smokers are there? There are 45 and 36. There are 81 smokers. What proportion of sampled smokers like risky things? Well, 45 of them like risky things. So what's the proportion? 45 over 81. So let me see if I don't have that written down. I'm not going to bother to work out that, but just describe the fraction. You could actually take out a calculator and figure it out. But that's the way we would figure that out. What proportion of sampled non-smokers likes risky things? Well, let's look at the non-smokers. Remember, we're only looking at non-smokers. That's what this describes. It's 46 and 153 non-smokers, bigger population. So it's going to be 196, 199 rather, right? Yes, 199, 199 non-smokers. What proportion of them likes to do risky things? Well, that's going to be 46 out of 199, right? 46 over 199 is a proportion of non-smoking teenagers that likes to do risky things. Okay, so let's see. I don't think was that it. I think that was it for that. Okay, so now at this point, we started to talk about where I got a number of questions. Was about how to handle this data NC birth data mod data set. I'm going to search for it right now. 800 mod.sav. Let me see if I can't find it here. Get a version of it. ncbirth.sav. Where'd it go? Okay, let me sort by kind because it must be mentioned in some of these documents. Let's see, PDF files. Yeah, we've been using this quite a while. Okay, here's a version of it here. Actually, you know what I'm going to do, just to make sure that I'm using the same version that you are, and nobody's been monkeying with. A lot of students will. There might be several on my computer that have been altered to demonstrate something or to change something, show what outliers do and stuff like that. So rather than chance getting one that's kind of different than the one that you were working with, I'm going to go on Blackboard. And I think most likely if I go on Blackboard, let's see if there's a version of it here. Quiz 1. Let's see. I don't see it. Maybe it's in a lecture. Probably week 2, right? Nope. Not there. Let me go back. Week 1, maybe. I'm surprised nobody mentioned to me that they have. Maybe it's in here. Nope. Don't see it there. Wonder what this is. Oh, here we go. Here's a copy of it. I'm going to right click on it and I'm going to save it to my desktop. Okay. Want to include that. And go ahead and save it to my desktop. Okay, in case you didn't find it before, it's in the exercise, in the folder called practice, week 1, SPSS and Excel exercises. Okay, so I'm going to go back to my desktop here, try and find it. Or actually, better yet, I'm going to go back to SPSS. Since I know it's on my desktop now, I'm going to go in here and say, oh, by the way, if I close this blank, even though it's a blank window, if I close this, it's gonna want to quit SPSS. You can't have SPSS like most programs with no running, but with no window open. So I don't want to proceed. So in order to open this, I have to first go to File, Open, Data, open a data file, and then navigate to where the data file is located. As it happens, I put it on my desktop. And here's the data file right here. I'm going to click Open. It's warning me about this difference in encoding over, between the old versions and the new versions. It's not going to really affect us that much. So I'm just going to go ahead and say, okay, go ahead and update it. Okay, so now here's my data file. Now let's take a look at this data file. Remember we had mentioned before that the rows represent the subjects. For instance, this is birth data. This is North Carolina birth data, 800 subjects, women who gave birth, 800 actual births actually, right? And these columns represent variables. For instance, some of them are pretty easy to figure out. Sex means the sex of the child, obviously the mother's female. MH is the mother's age, weeks of gestation, whether they're married or not, marital status, the race of the mother. Notice some of these are abbreviated as numbers, right? Like for instance, we at this stage don't know whether the baby, if it's a 1 here, we don't know if that baby was male or female yet at this stage, right? So I'm looking at the data view. Rows are cases, columns are variables. And there's 800 cases, so there's one line for each case. So let's go to the variable window. If we go to the variable window, I see that the name of the variable is here. Each row represents a detailed description of that variable. For instance, if I look at sex, right, what I see here at sex is numeric. It gives it a lot of space. Even if it's only 1 or 2, it gives it 15 characters of space. Doesn't really matter. It's not wasting anything. Okay, but it gives it also a label. And the label is sex of the child. You could change that if you want. You could say sex of the infant, sex of the new birth, or whatever. You could change that if you wanted. The reason why you have a variable name and a label is because the variable name has a set of rules. Number one, it's got to start with a letter. It can only be letters and numbers, can't be special characters, and can't include some spaces, right? So for instance, if you were to look at M age, mother's, we know that that's the age of the mother in years. M age, if you were to do calculations and produce tables and graphs, and on the tables and graphs it describes, well, this data illustrates the M age. That might not mean very much to someone who is looking at that chart or table for the first time. So what SPS will do, it will substitute the label that you assign it, which has a lot of, which is not constrained, in terms of like spaces and special characters, the way that the variable name is. So that will be printed on all of the tables and so on and so forth instead of MH. So if I continue along, the next important thing is values. Any of the categorical variables. Okay, so notice that MH is a scalar. You have 3 choices of variables: scalar, ordinal, or nominal. Nominal, the same thing as categorical. Ordinal is like good, fair, poor, and stuff like that, ABC, right? And scalar is a numerical variable. So you'll notice that age of the mother in years is a numerical variable, scalar variable, as you would expect. The plurality, the number of babies of that birth, is listed as a nominal variable. I probably would change that to scalar, right? Because it is a number. Okay, the gender, sex of the baby is nominal, right? That's correct. The weeks of gestation, right? The completed weeks of gestation. SPSS took a guess at this, called it nominal. It's really scalar, right? So sometimes you have to go in here and you have to, wake SPSS to get it right. Marital status. Okay, that marital status is categorical or nominal. That's good. The race of the mother, nominal. Whether the mother is of Hispanic origin or not, that's nominal. It's a yes or a no, basically. The weight gain during pregnancy is scalar. Whether the woman smoked during pregnancy is basically yes or no, so it's nominal. Alcohol during pregnancy, yes or no, nominal. Now you'll notice also there's another, for the nominal variables, there's another important column here which is called values. Okay, if I click in here to sex of the child, I click in there, there's a little box I can click into. It's already been input for us. The sex of the child, if that number is 1, it's a male. If the number is 2, it represents female. So now we know what the 1 and the 2 represents. If I want, I could actually add another variable, right? I could say 3, right? And I could say other, for instance, if that would make any sense. Doesn't really make any sense, so I'm going to delete it. But that's the way you would add another value in that column. Okay, and I'm going to say cancel, so it doesn't change anything at all. Right, this is the way it was. So if you look at ethnicity, let's look at the race of the mother. Oops, uh-oh. Let's look at the race of the mother. 0 is other non-white. 1 is white, 2 is black, 3 is American Indian, 4 is Chinese, 5 is Japanese, 7 is Filipino, 6 is Hawaiian, other Pacific Islander, and so on. Right, that's what all those numbers represent. Those are the different groups that were collected. The data about different groups of ethnicity that were collected. Okay, so if I go back to the data view, I can go into this data view and I can see that, for instance, ones and twos are male and females. Wouldn't it be nice if I could flip on and off that, if I could flip on and off that identity that shows what the 1 and the 2 is? Well, in fact, you can. If you go up to the view, you go down here to value labels. These things are toggles. If I go down here and select value labels, it will make those value labels appear. Bingo. If I don't want them to appear, I can go up to view. If I want to see the raw data that was entered, which was just numbers, I can turn that off as well. Doesn't affect what you do when you do your calculations, but you might want to be able to see male and female, for instance, if you're looking at specific cases. Notice the total, the ounces at birth and the grams at birth, and so on and so forth. Those are numerical variables, okay, in this column and in this column, okay. Whether the infant was low birth weight or not, right, is in this column. That's a 0 or 1 problem. Okay, so now let's say I want to do some exercise. Let me just go back to the quiz and take a look at what they might be asking us here. Using this data set that we just opened, what was the average mother's age in this sample of 800 women? Okay, there were way more births than 800 in North Carolina during the period of year when this was done. There were, maybe tens of thousands. Okay, now I'm going to have to figure out what this thing says here because it's buried. Right, what percentage of mothers in the samples were married? Let me see if I can't find something that'll show me what that thing says. I printed out these questions as well. Hopefully it doesn't show this stuff. So let me see it. See if the printouts did this. 5, 6. Let's see if I can read it here. Question number 8. Okay. What percentage of the average mother's age what was the average of the mother's age in this sample? What percentage of mothers in the sample were married? And what was the most common race and ethnicity in the sample? Okay, so let's take a look at this. I'm going to go back to SPSS. Just find it down here, it'd be a little easier. Okay, and I want to analyze this data. The first thing I want to know is what's the average age of the mother in this sample. So I'm going to go up to analyze, and this is most of the places. This is the place where you're going to do most of your analyses. Is up here at the top here where the drop menu for SPSS says analyze. Can you guys see that? Can you guys see that menu all the way at the top of my screen? I just want to make sure so that I'm not doing something that you can't see. I'm not sure how much of my screen that you can is actually being captured and broadcast. Okay, good. So I want to make sure. So we're going to analyze. I'm going to go to descriptive statistics because the mean is a descriptive statistics. Okay, so I'm going to go to descriptive statistics. Frequencies is something that we use for categorical or nominal variables. Frequencies means a count. How many male babies were born versus female babies? How many women are married? Right? That's a count. But in this case, mother's average the average mother's age. That's a descriptive statistic. That's a mean. So I'm going to go down to descriptives, and a window is going to come up. And there's a lot of variables here. So SPSS wants to know which of the variables, this is our box here for variables or dependents, which of our variables are we looking at here? Well, we're interested in the age of the mothers. I'm going to click on that and move it into that box. So now SPSS knows that we want to do some operation involving this variable. Now you may notice that you could also put more than one variable. So you could do the analysis for more than one variable at the same time. In this case, numerical variables. Okay, I'm going to go into options. And in options, you can see that SPSS is ready now to calculate the mean for me. I could turn all the rest of this stuff off since all I want is the mean. Or if, maybe I'll just leave them turned on. Variance, range, minimum, maximum, and so on. So maybe that might be interesting to us. I'm going to click continue. And then I'm going to click OK. And SPSS now will open an output window. The results always go to another window, which is called an output window. The output window is saved, organized, and saved separately from your data window. When you're done, you're going to want to save or export your output window separately from your data window because they exist separately. So here's our output window. So let's see, age of the mother in years. There were 800 women, a range of 27, 15 to 42. The mean age was 26.92 years. Here's our answer. The average age of mothers in this sample is 26.92 years old. Okay, we happen to do the standard deviation and variance calculated for that for us, but that's just a bonus. That's not what we were looking for. Okay, let's look at the next question. What percentage of the mothers that were sampled were married? Married, not married is a frequency, is a nominal variable, and now we're going to be interested in frequencies. Analyze again. Descriptive statistics. It's a nominal variable. It's going to go into frequencies. So what am I looking for? I'm looking for the marital status. I'm going to move that in there. I'm going to click on statistics. Well, this stuff doesn't mean anything. Mean, so on and so. That doesn't mean anything for that. In fact, I'm not even sure why in frequencies SPSS lets you see that. Charts. What's that all about? Hey, what kind of chart do we usually make for nominal or categorical variables? We don't make histograms, so we're not going to want that. We could make a pie chart, but let's make a bar chart. That's a little bit more common. And the frequencies, we could either have the actual numbers of women represented or by percentages represented. I'm going to leave it on frequencies there. Okay, and I'm going to click OK. And SPSS is now going to do an analysis and stick it in the same output window. So the output window comes to the front. Notice, look, there's more married women than non-married women. Looks like there are, out of the 800, 540 of them were married, and I don't know, 260 of them or so were not married. In fact, we can actually see that in the table it produces, right? It was actually 537 and 263, so 67.1% of the women are married, 32.9% of the women are not married. Okay, let's take a look at the next question they ask. What was the most common race and ethnicity in the sample? Well, again, that's a nominal variable, so I'm going to go back here, analyze, descriptive statistics, frequencies, except this time I'm going to move marital status back there, and I'm going to look for the race of the mother. I'm going to move that in here, and I'm going to leave everything else set up the same way. I'm going to click OK. What do we get here? Well, look, it's pretty clear that most of the women were white women. There were some black women. There were very few Filipino women, a few Asian or Pacific Islander, so on and so forth. So let's see what the percentages were. What did the question ask for again? Well, sometimes I get carried away and I forget exactly what it asked for. What was the most common rate? Oh, we figured that out right away. Even from the bar chart, we could tell that white was the most common ethnicity. Okay, right? Non-Hispanic white, H for, what was the most common race and ethnicity in the sample? I'm not sure why it did that. Did it want a W? Am I missing part of this question? Is that it? No, non-Hispanic white. NHW is non-Hispanic white. So that's what if I looked at the labels, if you go back and look at the labels, it probably says that. Let me go back here and let me go to the window, output window. Over here, the label says white, but I guess that somewhere in here it was identified as non-Hispanic white. Well, I don't see Hispanics listed separately. Do you? Well, that's what it is, white. Or in this case, non-Hispanic white. Okay, so what's the next thing it's going to look for? Certainly not non-Hispanic black. It's not Hispanic, and it's not other. So it's got this is the only one. This is the only one that makes any sense. Okay, even though they didn't really say non-Hispanic white, they just said white. What was the median mother's age? Median mother's age for mothers who smoked during pregnancy versus mothers who did not smoke during pregnancy. We're looking for the middle age, the median age. We could say average age, but they wanted the median age, right? For whatever reason. What's the median mother's age for mothers who smoked during pregnancy? And they want to know separately the median mother's age for mothers who didn't smoke during pregnancy. Well, this is a little bit of a thorny problem here because up till now, when we went up here to analyze descriptive statistics, descriptives, right? When we did this with the age of the mother, right? We got a mean, so we don't get a median here, do we? Okay, well, there's another way for us to do this. Analyze descriptive statistics. I'm going to go down to the next selection, explore. Explore is descriptive statistics also. Just everything in here actually is descriptive statistics, but this lets you pick out a little bit more information, get a little bit more information. So I'm going to put the age of the mother here into the box dependence list. Same as the variable selection that we did before. In statistics, I'm going to say, it's descriptive statistics. All there is a check to calculate them or don't calculate them. That's because it's going to calculate everything you'd ever want to know. So, for instance, right now it calculated that the mean age was 26.92, just as we saw before, and the median age was 26. But there's a problem now. That's the median. We can calculate median age with Explore, but we don't. This is for all the women, not separated by smoking and non-smoking. Okay, so now we come to our dirty little secret. By the way, you can also get box plot here, and you could get a histogram if you wanted to, and so on and so forth. I won't go into that right now. I'm going to go back here to Analyze, Descriptive Statistics, and I'm going to go back to that Explore. And right now, I have the age of the mother selected here. Remember, we're interested in the median, right? And I have a factor list. What does factor mean? When you factor in math, what do? You break things up in its component parts. For instance, if I told you to factor the number 15, you'd tell me 3 and 5. 3 times 5 is 15. You'd break it up into two parts. So I'm going to factor the smoking status of the mother. I think that's what we wanted. Smoke during pregnancy. And I'm going to put that into the factor list. So there's two selections that they smoked or they didn't smoke. So now, since that nominal variable is in the factor list, right, that's usually a nominal variable that's going to go here, non-numerical, because we want to break it up into groups. That we're going to be winding up doing these calculations, but breaking up the calculation for the age of the mother into one calculation for mothers who smoked and one calculation for mothers who didn't smoke. I'm going to click OK. And here we go. Now our table comes out with two groups in here. One group, the top part, is mothers who did not smoke during pregnancy, and the median age was 27. But mothers who did smoke during pregnancy. Not surprisingly, that's younger mothers. The median is younger for women. Even I guess the average would be mean is also younger for not dramatically younger, but younger, right? The median age for women who smoke during pregnancy is lower than median age for women who didn't smoke during pregnancy. So when you say, did we cover Explore? I think it came up briefly. We went through this really pretty quickly. in the I think in the first, in either the first or second lab, but certainly not that. Trust me, it's easy. We're doing so much so quickly. It's hard to remember this, but we did do a quickly look at that. I think in at least one set of I don't think with this data set, but we did at least take a look at it. How do I know to make a bar chart? Well, you would make a bar chart for frequencies, right? Bar chart would be for a categorical variable. Like if you wanted to know, for instance, let's go to analyze, descriptive statistic from, yeah, descriptive statistics, frequencies, and let's take a look at another nominal variable. For instance, the race and ethnicity, the two different things, ethnicity, right? I wonder if ethnicity was the one that had for instance, alcohol during pregnancy. Let's move that in there. Let's make a chart, and it would be a bar chart because this is a categorical variable. Because we just want to know one bar represents women that smoked, that drank. The other one, women that didn't drink. Obviously, very few women drink in this group drank during pregnancy, or didn't admit they drank during pregnancy. Okay, so if we're dealing with numerical variables, analyze, descriptive statistics, explore. Whoops, got the wrong one. Analyze, descriptive statistics, explore, like we just did here. If I go into plots, I can ask it to give me a histogram, not a box plot, but a histogram. Continue. Okay, it's actually going to give me two histograms because that was the version that we did. So here's a histogram for women who smoked, right? This would be the ages, right? This is the histogram. Looks pretty normal, maybe skewed a little bit there. Okay, and this is the histogram for women who did not smoke during pregnancy, right? So it could produce histograms for us, right? And this definitely looks like it's skewed towards the older. Average age was old. Some more of the older women were smokers among the group that smoked, even though the median was younger than this group, right? It was skewed to the right, it looks like. Okay, so the mean would have that. In fact, we saw that, didn't we? The means of these two were closer than the medians, right? So this skewing had more of an effect on the mean than it had on the median, right? So for whatever that's worth. Okay, so that's why you would use that. So use the explore when you want to get more statistics than the explore descriptives and explore. Frequencies is for nominal variables. Descriptives and explore are for numerical variables. Explore gives you more information and more options and allows you to factor the data into different groups so you can compare, you can split up a numerical variable into different groups, like I could do the average age for ethnicity by ethnicity, for instance, if I wanted to. So that's how we would deal with that. Let me just make sure we're getting on to 10 o'clock. I don't want to stretch these things out too long, and then people will not want to hang out with me for very long. Trust me, you can get tired real quick. What was the median age from others? So we did that. Question 10, was there any outliers in the mother's age in either the smoking status group or the non-smokers? Hint, side-by-side box plot. Guess what? I'm going to go back here. Analyze, descriptors. I'm going to do it again rather than worry about, whether or not. So we got what we need here. SPSS, in addition to doing the histogram, stem and leaf automatically, doing those, they kind of usually checked off by default anyway. It'll automatically do a side-by-side box plot for you. Let's take a look at that side-by-side box plot. This box plot represents women who smoked during pregnancy, did not smoke during pregnancy. This is mothers who did smoke during pregnancy, right? So I'm looking here, and the median for mothers who did not smoke is older than the median for mothers who did smoke. And this is in the center, so this is skewed. This one doesn't look skewed. This one does look skewed because it's not in the center. It's skewed positively or to the right, as we saw when we took a quick look at it as a histogram. Okay, but so we see the median of one is different than the median for the other. The median age of mothers who did not smoke is older than the median for mothers who did smoke. Now, if there were outliers, we would see them as values that are circles or stars. that are outside of the box plot. So it does not look to me like there are any outliers here. There are not any mothers that are in this group of sample of 800 that were like maybe 55 years old when they gave birth. Now, this is pretty old data. So I have a suspicion that fertility counseling and technology was not very advanced then. If you did this today, you might find someone that's 60 years old that had a baby right here. That would be an outlier. That would be so far from the bulk of these values that we would have to think about whether or not to include that data. If there's something unusual about it, they use drugs or some other therapy or whatever to achieve that, or whether it really should be considered as part of this data for one reason or another, and how to handle it because it's so different than the rest of the data. In other words, it's an outlier in a sense that it's very different, right? But since we don't see those stars here, that would say to me that, gee, I don't think that there's an outlier here. Let me see if I can get one that might have an outlier. I'm going to finish up real quick here now. Don't go away yet because I'm going to get out of here. I'm going to give this up soon. Okay, let's see if I can. Mother's age. About weight. How about the weight of the child in ounces? Okay, I'm going to do the weight of the child in ounces. I'm not going to bother. I'm going to move this back. I'm just going to do the weight of the child in ounces. I'm going to ask it to do, it's going to do a histogram and so on. So it's going to do a box plot. So I'm going to display that. And here's my box plot. Oh, look at this. There were a lot of babies that were very, very light at birth, very tiny at birth. Those are premature babies, right? The bulk of the babies are in here. But there were some babies that were so different that SPSS is displaying them as outliers. So basically, it's forcing you to consider, well, what should I do with all these premature births? Should I include this in the data, or is there a reason why, or how should I handle this data? So this is way a box plot would display outliers. And SPSS kind of has a way it calculates whether something's an outlier or not. I believe it's something like 1.5 times the top quartile marking. If it's beyond 1.5 times the top quartile marking, it describes it as an outlier, something like that. But for our purposes, it uses its own internal rule. You could use a different rule of your own if you wanted to identify outliers. So let me see if I got everything done here. Any outliers? No, there were no outliers, and I think we're all done with those 2 quizzes. So good luck. And email me if you have any questions on quiz 3. Email me. I want you guys to get a chance to do it on your own. But if there's any, if you're really stumped, email me and maybe I could rather than try and assemble all you people into something organized like this, maybe at that stage I could just like a little quick video to answer those individual questions or something like that. So you guys okay on this? You're okay with what stuff on assignment quiz 1 and 2, and you're doing okay on quiz 3. Hopefully, work on it over the weekend and email me. But please, in your emails, remember, put BIOS610 in the subject line, right? So that I don't miss it.